Hello again, and welcome everyone to the Virtual Design Master Season 2, First Judgment. This is Challenge 1. For those of you who watched last week, you saw that we had our array of amazing challengers that have been presented with an incredible scenario. In the first scenario, they were presented with a fairly open-ended option where they had to take any kind of design that they wanted to do, present design, the diagrams, and everything behind it. And this is the kind of work that we are amazed by when we see them coming from Virtual Design Masters, like the teams that we have here in front of us. Our teams are in fact split up. So as you can see, we've got our Team Alpha group in front of us right now, as well as our judges panel. So again, as we mentioned, we've got a great array of judges. Some are going to be offline and some are going to be online. First of all, we have Josh Atwell here with us as well this year. Josh is a previous judge from Season 1. Welcome back, Josh.
Hey, Eric. Thanks for having me back. Angelo, appreciate it. Really excited about what you guys did last year and looking forward to what the much larger field is going to do this year. So far, reviewing designs should be a good one.
It's definitely going to be a lot of fun. We also have from across the globe Mr. Josh Odgers, well known as VCDX90 and much more. Josh, welcome back again for episode 2, I guess we say.
Yeah, excellent. Yeah, thanks for having me again. And yeah, it's been great to review the designs from all the candidates. And yeah, looking forward to the challenge.
And of course, we also have Brian Kirsch. Brian, welcome back again. It's great to have you aboard. For those folks who don't already know Brian, of course, you can see from his tag there, he's at vbrains.net, and as a zombie brain eater himself, he knows what it's like to be on the wrong side of the apocalypse.
Thank you very much. Thanks for having me.
All right, so we've got our entire group of Team Alpha in front of us. So we are proud to welcome. We have Anthony. Anthony, welcome back again.
Thank you.
Byron. And Byron is welcome aboard. We have Damon coming to us from another beautiful Canadian city, Vancouver. We're kind of partial to Canadians here. We have Jeff as well. Jeff, welcome back. We have another Canadian among the group. We have Mr. Joel Gibson joining us right now. How are you doing, Joel?
Good. How's it going, guys?
Very good. You're actually inside a home today. This is good.
Yeah, exactly. There's a story for another day.
Exactly. Okay, so as I mentioned, this has been an incredible event, even as it's just begun. We've got a sea of people that are helping to support this event. As you can see, we have an incredible team that's been built around this. Normally we have the rest of our production crew. Melissa Palmer, who's our creative designer, wasn't able to join us tonight. She's out fighting zombies in data centers as we speak. We also have Jonathan Frappier, who's supporting us on the social side because we ran out of spaces in our Google Hangout. Jonathan has been helping a lot with a lot of the coordination, and we're going to see Jonathan come back. Of course, you remember Jonathan from being a competitor in Season 1. We talk about the support that we have here. Luckily we've got friends like Zerto and Veeam, HP, VMware Press who are supporting us as well, and we also have IP.net. You'll of course know Ivan as at iOS Hints online, and Jason Langer as well, representing from virtuallanger.com, and Jason's brought some great Amazon gift cards as well for our winner. So to talk about community, that's exactly it. Not only are there great companies that are behind what we're doing here, and they're great people, both participating and supporting the overall event. So for folks that want to participate online, we of course encourage you to use the hashtag #VirtualDesignMaster. And as I talked about earlier today when I tweeted, I said there's actually going to be a viewer portion for people to win. Now Ivan from IPspace.net has an amazing set of seminars that he does on everything from soup to nuts in deep, dark networking, and lots of other great virtualization information in there. So Ivan is kind enough to not only have opened up his site for our own competitors, but he's also opening up for a few lucky winners. So we're going to have an opportunity for people that are viewing online to be able to go, and we're going to have a tweet contest that we're going to detail a little later on. So Angelo, I guess it's time for us to get down to business. Again, everybody who's seen our challenge, they know what they're facing, and we had a great set of design documents that came in. We want to go through and talk about them. So Angelo, I'll turn it over to you, and you can take care of getting our folks to do their defense.
Thanks, Eric. First, let me say, great job, everyone. The design submissions were incredible. It was more than what I was expecting. So great job. Because I know you folks have jobs, families, and life gets in the way. So it's just incredible the amount of effort that you guys put into it. And I also want to quickly mention the great job that you guys have been doing on Twitter using hashtag Virtual Design Master. It was great following the conversations and the photos that people are posting. Just particularly VMUG Vancouver. Great little pictures you're posting out, and little awesome. Really keeps the spirit of the competition alive. So really like that. Now I have the I guess the pleasure of being the bad guy here, sort of. So I am going to give each of you 1 minute to explain and defend your design, and I will cut you off if you go over a minute. So don't take it personally. We're just trying to keep we're trying to respect the time frame we have here, so we get both groups online. So we're going to start with Joel. So Joel, I'm going to give you 1 minute to defend your design, starting now.
So really the basis of my design was I wanted something that was going to be simple, and the key about being simple is I wanted it to be reproducible. The way I looked at it is that each of these spaceports would be completely independent. I really didn't want to have a lot of interconnectivity between them besides just basic networking. So ideally, I should be able to, rack and stack one of these designs quickly and be able to support it in a, well, I shouldn't have to do a lot of support because, quite frankly, most of the design was automated. I chose to use Puppet for automating the OpenStack infrastructure that I chose, and then I specifically went with OpenStack's own project for automating the creation or the scaling up and scaling down of the application level VMs. Cassandra was the database I chose, again, on the application side, because I wanted the ability to be able to scale up very quickly and use it essentially a distributed nature.
Okay, Joel. Thank you so much. I'm gonna cut you off there. That's great. And I should add to folks, we will be posting all the design solutions once the after today's hangout. So get ready to see some really good stuff. So I'm gonna ask Brian if he has any comments, questions for Joel on his design.
Hey Joel, I noticed you went with the KVM OpenStack solution over, let's say, like a vSphere solution. Why was that?
So initially I was going to be doing vSphere, and a few things that really came to mind was I wanted to be able to keep it simple. I didn't want to have to worry about some of the licensing in the vCenter. When I started, basically I wanted to use OpenStack as the foundation, and when I started thinking, okay, I'm going to add OpenStack and then I'm going to add my vCenter server on top of it to really be able to get the benefits of using ESX, I basically turned it all around and I said I wanted to simplify the design. There was no point in me using free ESX in combination with OpenStack because of the memory limitation. So I wanted to be able to use something like KVM, and also I've even seen these comments in the Twitterverse too, but we don't know what sort of support would be available through these proprietary vendors. So one of the things I noted in the design was I really wanted it to be community supported.
Okay,
Great.
thanks.
Great, guys. Thanks. Josh Odgers, any questions for Joel? Comments?
Oh, I think the obvious one is he's gone with the Nutanix solution, so clearly a brilliant choice. But no, I was just going to say, sort of echo the previous questions, which was using an open source versus a proprietary system. Do you feel that there's any risks in doing that, where you've only got community support versus a commercial platform, which might have had more QA and things like that?
Yeah, good question. So I think with OpenStack, we've got the best of both worlds. We do have that open source community, but at the same time, we've got so many proprietary vendors that are standing behind it that going with that sort of a design, even though I did chose to go the community way, I felt there would be enough support even from vendors behind that sort of a product.
Okay, thank you, Joel. Great job. We're gonna move on to Jeff. And get ready, Jeff. Your 1 minute starts now on defending your design.
Okay, so I kind of chose to basically 2 orchestration platforms. Mostly VCO, just from the fact that I used Cisco hardware, Cisco UCS pieces. I used SolidFire storage, and I used an SAP, basically an application system. SAP has inherent orchestration abilities within it, and I wanted to choose a manufacturing application that could touch all aspects of the manufacturing facility. So it makes sure it automates all the pieces of equipment that would need to be touched in the environment. The reason why I went with the Cisco piece is that I felt that it was a very easily reproducible type of platform. Basically, I can export the service profile and then just buy the same hardware for each site and then re-import the service profiles.
Okay, Jeff, great, thank you. Josh Atwell, any questions for Jeff?
Of course.
Of course he does.
So I want to start with that. I was really pleased to see that you highlighted the management infrastructure and separating and providing that. You weren't the only contestant that did that, but when I was reviewing, I was really happy to see that. It is kind of important when you're looking at availability. One thing I was concerned about and I wanted to ask, and it wasn't the SolidFire piece. That was a fun surprise. But I was curious about the why no other sites. Why weren't you prepared for other sites? I do see that you had replication between the racks, which does provide some additional availability if you were to lose a rack. But there didn't seem to be much about the moon or Mars or anything else.
So when I originally did my first kind of high-level design of this thing, I took a look and I did some research on latency actually from communications between Earth and the moon. And there's some new technologies and so forth that are going to enable some faster level communication. But I think when I looked at it, I think the latency that I had found was something like 1.5 seconds for a 2-way communication between the Earth and the moon. So what I did was, when I picked SAP, when I built the infrastructure for this, the SAP application itself, this can be siloed or you can distribute it out. So when you take these sites, if we spin up a new site and I bring this architecture over to another site, the MII, the Manufacturing Intelligence Integration modules, those pieces can be controlled centrally if we decide to deploy another base on, say, the moon.
Okay.
It was an assumption that I took, that there was no outside places.
Good work. Good, thanks, guys. Brian, do you have any quick questions or comments for Jeff? I think you're muted, Brian.
Okay, sorry about that.
It's okay.
I definitely like the fact you included a backup solution. A few folks didn't, so I loved how you separated out your management. Thought you were a little stingy on your memory for your hosts. I would have probably upped it a little bit just for in the event of a failure because you're using blades, just to give yourself a little bit more elbow room. I was kind of curious why I think you were at 128 or 192. I can't remember.
No, so the systems I used were the C240 rack mount servers, and I put 384 gigs of RAM in those, and that was to keep the memory at 1866. That was the highest config that I could do to keep the memory speed as high as possible. Yep.
Okay.
Okay. Great. Good work, Jeff. Okay, you're off the hot seat.
Thank you.
We're gonna go to Damon. Damon, you have 1 minute to defend your design starting now.
Okay, the way that I approached it was resilience and redundancy was the most important thing to me to ensure that the lifespan of the project, the 72 hours, that was critical. So I went through every single component. I looked at what would be involved in order to make sure that we can do continuous development and continuous integration on the software side, as well as on the hardware side. So I divided it into 3 different sections. So you have your development section, then your QA and fabrication section, and then you'd have your actual production section. So the production was key. I had to make sure that that was 100% reliable, and that's where I went with a UCS solution. I went with clustered on tap. There's multiple levels of redundancy at every single level, so I could lose large portions of the infrastructure and keep things running with the 100% service level objective.
Perfect. Just under a minute. Perfect. Josh Odgers, any comments for Damon?
Yeah, look, I think this design stood out for me in one way where a lot of design decisions have been called out specifically, which is one of my little pet things that I do on my blog. So I thought that was very good. One comment I would make was there wasn't a lot of justification for some of those decisions. The one thing that concerned me was the solution was quite large day one. So I was thinking from a complexity and implementation perspective, what sort of delays that might have, as well as logistical issues if you had to actually move that equipment between sites. So I'm interested how you would how you've mitigated that sort of a risk.
Well, one thing that I said in the design is that all extra equipment that needs to be added would be in a warehouse location that's very, very close and accessible and protected. I went with the large maximum amount of chassis for the UCS domain in the event that we can't get to those warehouses if they get overrun by zombies or something else like that. So we had that built up in place. And one of the things that what was given in the parameters of the design is that we can have as much hardware day one as possible, as opposed to building it up from scratch.
Okay, great, Damon. Josh Atwell, any comments for Damon?
Yeah, first thing, one thing I love about Virtual Design Master in the scenario that we have is that there's lots of opportunity for Easter eggs. I fully appreciated the assumption that the staff was going to receive everything that they needed, including coffee, so that there wouldn't be loss of life. So well done on that. I did. Overall, I agree with Josh. I liked your design. I had some confusion about why you made some choices, so I'll just pick one because it's really important for other organizations and people when they're doing design. Why no RDMs? You specifically highlighted that. Why did you highlight no RDMs in the environment?
I want to make sure that in the case of replication from one site to the other, RDMs are going to add complexity. And there's no need for them with a vSphere 5.5 because I can do large VMDKs and there's no real performance difference at that point.
That's a perfectly acceptable answer for me.
Thank you. Good stuff. Good stuff, Damon. Okay, great. We're going to go on to Byron. Byron, I'm going to give you 1 minute to defend your design starting now.
I'll go to start. I have a 2-pod design of a management pod and an application pod. The management pod is running BCAC to do all the provisioning of the application pod. That goes on through 4 or 5 different steps. The first is it deploys CoreOS as the base image, and then on top of that, there's 4 other advanced workflows using VCO that step in with SALT to deploy Docker containers of each tier of the application. I also use Cassandra as my backend, as well as Nginx and RabbitMQ. On the hardware, I used all UCS, including unified ports on a Nexus 5596, back to Pure Storage.
Great job. Good. Josh Odgers, any comments for Byron?
Yeah, Byron had the best design constraint I've ever seen, which was the only storage vendor to survive the zombies was Pure Storage due to the amazing fighting prowess of Vaughn Stewart.
Yes, that was brilliant. I want to make sure I...
Have you met that guy? There's no way he dies in the apocalypse.
So, absolutely, Vaughn Stewart would survive anything, so that's a fair call. What I was going to comment on was use data store clusters, which I thought helped you mitigate your scaling potential issues as far as capacity is concerned. But I wanted to touch on this point because I think it's valid for most contestants. You've used proprietary hardware which might be in short supply and also that could be considered complex. So I'm wondering how you justified the use of that hardware versus commodity hardware, or just you've gone with the HP or a Dell or something like that.
Sure. So there's two reasons. First, on the UCS, I wanted to get the Nexus in there because the unified ports, so we could have the fiber, 10 gig and 1 gig all on one switch. That kind of to simplify the overall pod. And then on the Pure side, I just really like their technology. I think that their speed and resiliency, and especially the replication between nodes, is really great. And I thought that I wanted to use the fastest solution to scale with the least amount of hardware and provide the most IOPS I could.
Great. Good, Byron. Brian, do you have any comments for Byron's design?
Yeah, Byron, you talked about using admission control to prevent issues, prevent certain things from starting up. One of the pieces was always available. Things had to run because of, zombie apocalypse. Using admission control, you could potentially prevent certain VMs from starting up. Wouldn't running slow be better than not running at all, or your thoughts?
No, that's a good point. I actually hadn't thought of that. The reason was mainly for the management cluster side of things, where I was requiring N+2 just to make sure that we had the resiliency there. Because really, I wanted smaller failure domains, so that way, if one piece did fail, then it would not affect everything in total. On the management pod, if you lost 2 hosts, you'd be totally hosed. I mean, VCAC wouldn't be able to provision, and that would cause all kinds of other issues. Just because of the demand that would have been placed on both those 2 hosts that were left. So I thought that admission control was important to really keep that resiliency. It's less so on the app pod stuff, but definitely the N+2 was needed on the management side, I thought.
Okay, great job, Byron. You're off the hot seat now. Good job. And finally, we're going to go to Anthony. Anthony, I'm going to give you 1 minute to talk about and defend your design starting now.
The approach that I have for the design is mainly for security because human life is at stake. So in the design, I mentioned about data integrity. We need to keep the data intact. Even 1 bit is off, then the spaceship may not be able to build correctly, and then we will be not able to move to the moon. And this is one thing. Another thing is availability, because we only have 72 hours to build the ship. So the system has to be available up as much as it can be. And another thing is that I have specifically in the conceptual design stated that the technology used has to be proven technology. We have no room to try for new technologies, even though they may be the later or the greatest, but there could be bugs. So I think one of the requirements is that for the design, it has to be some proven technology that we have used before, and then we will be able to play safe in that sense.
Excellent. Right. Excellent, Anthony. 1 minute on right on the nose. Good job. Josh Odgers, any questions or comments for Anthony?
Yeah, the main thing I wanted to call out was one of the assumptions you made. I thought was very good, that you said that technical personnel to support the project might not be available, and I thought that was very a good consideration, because you're in a time where resources might be difficult to come by. So I thought that was good. So how have you mitigated that situation in your design?
Josh Atwell, any comments for Anthony's design?
Yeah, I wanted to ask Anthony. I liked your design overall, but I was really. Oh, sorry, I have a child that just got upset in the background. But I did have a question based on what you were just saying there about security and the viability of the technology. Yet you said as a design requirement of 100 gig links in the environment. That seems pretty high.
Anthony, any comments?
Yes, because for whatever available, 100 gig is to ensure great throughput. For me, this is my first design, and I am still stuck with the logical design for it. I don't have any too much specific, but one of the requirements is that I have to, whatever I can use, I use the fastest and the most high power compute and also for storage. This is the one thing to ensure that the overall design will be with the highest performance that it could be.
Okay, that's, sorry, go ahead, Josh.
Yeah, I just wanted to follow up on that. While I find that reasonable, I think Josh Odgers makes a good point that in this scenario, there may be limitations as to what's accessible and what people are able to implement. So while I understand where you come from, I did find that a little bit challenging in your design.
Okay,
not bad, just challenging.
Yeah. Great. Okay, Team Alpha, that was fantastic. That we got some really great insights from the judges. What we're going to do now is we're going to be announcing who does not move on to the next round at the end of the show. So we'll wait for Team Beta to come online, and that's when we'll discuss who will not continue in the competition. So I think I'm going to throw it back to Eric.
All right. Well, we do also, you may notice that Alex Ramirez was not able to join us tonight. He's had a time challenge. So maybe what I'm going to do is I'm going to start to clear the deck of the folks that are on here. So just so we can get ready for Team 2 to come on. Or in fact, if the Team Alpha guys want to just drop off, that'd be great.
Thank you, Team Alpha.
We're going to jump on and talk to Brian real quick, and let's talk about Alex Ramirez's design and see if you have any comments on that one.
Hey, with Alex's?
Yeah.
The issue that I saw with his is he didn't have a dedicated management cluster. A little bit lower end memory on the blades, but it was really the lack of the dedicated management cluster that kind of was an issue for me.
Okay. Josh Odgers, any comments on Alex's design?
Yeah, look, I thought this one was quite comprehensive in that he's thought about a standard shipping container to actually host his data center infrastructure in, and that would be suitable considering the state the world's in at the time.
Yeah.
He's considered WAN optimization, which I think is quite critical considering we're talking about communications to the moon or to Mars, where latency will be a big factor.
Yeah.
And then the only other thing I would say is he's called out his requirements, constraints, assumptions, and risks quite well. However, I would say the solution is very complex. So one of the requirements is ease of deployment, which I think would be quite challenging with a solution that's so complicated.
Okay. Josh Atwell, any comments about Alex's design?
Yeah, I kind of follow suit with Josh in that I felt he had a very comprehensive view of everything that needed to be considered. Unfortunately, I kind of felt like a lot of it was more of kind of a guideline rather than a design. And, these are the things that you need to consider rather than, in some cases, I didn't feel like he was providing solutions to those things. It was a good design for the most part, but there was a lot of stuff that was mentioned that didn't feel like a design. It felt more like, don't forget this.
Got it. Yeah. Great insights, guys. We really appreciate it. Eric, I'll throw it back over to you.
Great. Okay, well, we've got the most of the heart of Team Beta in front of us here right now. We want to welcome back our team, fellows. We put Team Alpha through the mill just now, so it's your turn to get your feet to the fire. We have Rob Nelson joining us. We also have Seth Forgosh. We have Timothy Patterson with us as well, and we've got Sean Massey is hopefully on his way. But in the meantime, as you may have seen from the first part of the broadcast, Angela's going to tag you. You're going to get 1 minute to offer your general defense on what drove you to make your design choices, and then you're going to get a couple of quick questions from the judges. And then at the end of it all, we are going to talk about the unfortunate news, and that, of course, we can't bring everybody forward with us. And not only do zombies take lives, but unfortunately, virtual design master judges do as well. So we're going to have to shell a couple of folks as we move forward into the competition. Again, these designs are incredible. It's a sign of the strength of this community and the power of minds that are in this community. So definitely, when we talk about people that are going home in this competition, it's not about them having a poor design, but they're effectively going up against some of the toughest competition that's out there. And so it's just a matter of, sort of design structure at that moment and how it weighs up against in this particular scenario. Oh, and there we've got Sean as well. There we go. So we are fully faced with Team Beta, and we also had Tom Howarth. I forgot to mention that Tom wasn't able to join us as well from Team Alpha. So that explains everybody's locations right now. So Angelo, turn it over to you, and you can tag our folks, and we can get our second defenses.
Great, good. And again, to Team Beta, great design documents. I know we put you under a lot of pressure to complete it, but you guys really produced some quality material. So great job. You should be really proud of that. So now we're going to start with Rob. Rob, we're going to put you on the hot seat. I'm going to give you 1 minute to defend your design starting now.
All right, who doesn't love to go first? So the goal was to save humanity by running an automated manufacturing plant. I tried to take that a step further and make sure that we're not only saving humanity itself, but also humankind's heritage and seed it to the stars with us. So each data center is not just independent and automated via VCAC and Puppet, but self-contained to join our colonists and provide each ship a fighting chance. But also when it's on the ground to leverage some connectivity that's available. The design's based on VMware, UCS, NetApp, Synology, Puppet. These are all common technologies that people who might be available would either know or be able to learn quickly. Everything was made to degrade gracefully via some scale out and port underutilization to provide both resiliency on Earth and when the system. And the manufacturing system itself that's based on VCAC and Puppet was designed to leverage some continuous development, continuous integration techniques to ensure a lot of flexibility for the developers and some development in QA environments to meet the SLA.
Okay, good job, Rob. Josh Odgers, any comments for Rob?
Sure. So what I found, there was 2 areas which I thought were quite good. You've called out all your requirements, which I always harp on because I think that's very important. The 2 areas that I was most interested in was the network design and the storage design. So if I focus on the storage design, you've got a NetApp solution, you've got a whole bunch of enterprise capability there. I was a bit surprised that you didn't use the snapshotting capabilities like Snap Manager and BSC and things like that from a capacity optimization perspective and speed of backup. So I'm just wondering why you chose BDPA.
A familiarity with it. My knowledge base with some of the storage solutions isn't as large as some other people, and I'm familiar with VDP and VDPA, so that's what I went with.
Great. Josh Atwell, any questions for Rob? Comments?
Yeah, actually, Rob, I thoroughly enjoyed your design overall. You even included a photo from my hometown, Raleigh, North Carolina. That made me laugh. One of the things I was really curious about was you did a really good job of designing for life and highlighting areas where they need to be reevaluated and things that need to be looked at again. I think that's critical for a solid design to have longevity. But one of the things that I didn't feel that you accounted for is what was being done in case there was a dramatic reduction in personnel. Given that Zed may come in at any time and wipe out half of the team, what are the considerations there?
Yeah, and that was a huge risk. I tried to highlight it at least as a risk, but yeah, ways to address that. I didn't really come up with some great ones, but I tried to make sure that the system itself would keep running even if most of the personnel was gone. Through the automation with VCAC and Puppet, things should be relatively self-sustaining. The watchdog processes that are in there would make sure that the manufacturing system either scaled up or scaled down to meet what's actually happening.
Great, good job, Rob.
Thanks.
Great. We're gonna go over to Sean now. Sean, I'm going to give you 1 minute to defend your design starting now. Sean, I think you're on mute.
Oh,
Okay.
Okay, so I guess I'm in
Start.
good company. I guess I'm in good company with that. So where I started from was that the zombie apocalypse, the return of it, was a surprise. So there was only one actual facility in production. The other were just coming up online. Everything was sort of being pushed out, untested, unoptimized. It was kind of a, well, we have part of an application, but we don't have time to wait for it. Let's get it in place. We have performance concerns. We're just going to throw hardware at it to fix it till the developers can get around to it. Tried looking at doing a lot of automation. I included sample PowerShell scripts, which would be deployed with vCenter Orchestrator, which are based on some real-world scripts that I've worked with. Overall, I tried to look at doing scale-out technologies, picking things I was vaguely familiar with at least, was not trying to push too far into territory I didn't know.
Okay, great. Good. Just under a minute. Fantastic. Brian, any comments about Sean's design?
Sean, why did you go with the rack mount versus blades?
My consideration was going with rack mount over blades was that if this progressed to a point where hardware availability became a concern, I could go out and raid a data center and find a bunch of rack mounts, throw them into my environment. Blades, I may be a little bit more constrained because if I go with UCS and the nearest data centers are Dell and IBM, well then I'd have to make sure I pull those chassis out, make sure I understand the technology there, whereas rack mounts, doesn't matter if it's HP or Dell, IBM, whoever, they're pretty much the same because they probably all come from the same component factories.
Great, good. Great. Josh Odgers, any comments for Sean?
Yeah, so one thing that I find interesting in virtual networking designs is a lot of the time people use a lot of V switches or DV switches. So in your design, I think you had a VDS and 2 VSS switches. So why wouldn't you consider converging those and using something like network I/O control? What was the advantage of separating those out?
Okay. All right. So my thought with doing standard switching for the storage was that I know VDS generally runs if vCenter is not available. But if there is an issue where I can't get my vCenter back right away and I need to make a change or I do experience a problem, I still wanted my storage to run independent of that. So that's the reason why I mainly looked at standard switching. I believe that was on the storage part. Yeah, so trying to look back at my design here quickly. A lot of this was written at 2 in the morning with caffeine-fueled. I believe it was more to segregate the storage from the VDS and the data vMotion.
Okay, great, Sean. Thank you. Okay, we're going to move over to Seth. Seth, I'm going to give you 1 minute to defend your design starting now.
All right, so I went with a FlexPod architecture. That's NetApp, Cisco, and VMware. I went with that because I wanted to have a repeatable process, something that could easily be deployed at multiple sites in a repeatable way. I went with standard vSwitches. Again, going around the idea of simplicity. I wanted to keep it fairly simple on the networking side. And for the orchestration pieces, I went with WFA, Workflow Automator, VCO, and Cisco UCS Director.
Great, good job. Josh Atwell, any comments for Seth?
Yeah, Seth. I thought your document was good. It was formatted well. It was very easy to find information. Something that's really important in a design. I think you're very optimistic that ntp.org is still online. But I think that's great. It's fine. My one concern that I had with your design is it felt much more like a proposal than it did a design. It felt much more like these are the things that I'd want to do rather than this is how I would put it all together and how they interact and how they deliver to the application. It wasn't that was the general feeling and theme. And so my final question, or I guess the question I would have is, what was the deploy time for this design?
So in general, standing up the hardware should be fairly quick. It should be a day, 2 days max. The application, I'm a little bit more vague on. I didn't go into quite as much detail as some of the others with the application. Again, the networking, I kept it fairly simple, so that shouldn't keep things from getting deployed. So I would say it should be a fairly quick deployment. I did go with a lot of hardware, again, because we didn't really know what our constraints were, and I was concerned that we may not have availability later on. So that was kind of the guiding principles I went with.
Great, great. Brian, any comments for Seth?
Really, just kind of a little bit was a little concerned about some of the details as far as you know you listed out the flex pods, but a little bit I guess to echo someone else's comments, a little bit more of a guideline document than more of a design document. I was also a little concerned with the portability. It seemed that you could possibly fit it in a shipping container, but it did seem pretty heavy, shall we say?
Sure. So I did look at the specs for that mobile data center, and it did fit actually with room for expansion into that envelope. I did add that as a twist because I did want to be able to account for things like the site being overrun, and if we needed to move quickly, I didn't want to lose all the equipment that we had in place.
Okay, great. Good job, Seth. We're going to move over to Timothy. Hey, Timothy. And you have 1 minute to defend your design starting now.
All right. Well, I took kind of a gutsy move considering everyone's VMware background, and I went with a design based on AWS. They have one surviving region with 3 data centers contained inside of it. And when I looked at the application requirements, it became an obvious choice for me. We need a queuing layer, we need a database layer, and it had to be highly scalable and very elastic. So all of the components in my design are designed to be reused. You can run one cloud formation script, the entire data center, and the application stack is contained within code. So if Amazon fires up a new region, run the script, you have the complete stack built for you again. I'm taking advantage of built-in services like SQS for the queuing layer, RDS for the database layer. Could have went simple DB, but I wanted to keep it explainable. And all of your worker nodes and everything are protected by auto-scaling groups, so they grow and collapse as the workload increases or decreases.
Great, good job, Timothy. Josh Odgers, any comments or questions for Timothy?
Yeah, Timothy, I thought the design had a lot of strengths from a deployment perspective. Certainly you could deploy to Amazon quite quickly. I think that's quite critical in this kind of scenario. So what I thought was the issue with the design was that if AWS had an issue, you were kind of dead in the water. I didn't feel there was any mitigation there. So I'm curious how you would mitigate the risk of an AWS connectivity issue or just the provider itself being offline or unavailable.
Sure. Well, taking a look at AWS's backbone, I mean, they're connected everywhere across the world. I did list out in the risks of my design that in order to access the front-end application, you had to have internet access. But what I didn't specify is that has to be from your manufacturing facility. You can do it from a smartphone. Anywhere in the world, you can find an internet connection. You can connect back to the data center. I had asked the question before the competition started if AWS was a valid option considering the zombie apocalypse. And Amazon's always super secretive about their data centers. The physical locations are very hard to discover. They're kind of clouded in a shroud of secrecy and highly secure. So my thought was, well, if even a lot of Amazon employees don't know where the data centers are, how are the zombies going to find it? At the same time, I also listed a contingency where Amazon had already been planning to deploy a new region on the moon. So that's also a factor there. I used CloudFormation, like I said, to encapsulate the entire stack into code. So once that region came online, you execute there and you have a duplicate stack running up on the moon.
Great, good. Josh Atwell, question or comment for Timothy?
I thought it was very, very interesting that you did AWS. Since Josh already touched on the availability, I'll go to my my next thing. It was I guess it was kind of challenging for me. How could you have made it a little bit simpler and a little bit more accessible? I mean, it was really good seeing all the application stuff, but it felt really complicated. But maybe it's just my inexperience with AWS.
I guess I'm wondering what parts you feel were complicated. I kind of laid out exactly the network flow.
Oh no, it was a great design. It was a great design. I'm not saying that.
Yeah, I had kicked around actually going the route of some of the other competitors, maybe using VCAC, Cisco UCS, but it's just the simplicity of using services that already exist. Like Amazon SQS, the queuing layer, guarantees message delivery. It's just a service, API calls from your application. RDS, they manage your databases for you, fully online all the time with automated replicas.
Yep.
Okay, that works. And then what really set this design off in my head for me was the use of auto-scaling groups. So the manufacturing process, you can throw as many loads as you want into the queue, and these worker nodes are just going to sit there and wait. If they start to get overloaded, they will dynamically expand. You can fire up to basically an infinite number of scaling nodes, assuming Amazon has the capacity.
Yeah, all that's fair.
Do the workload as quick as possible.
Yeah, Josh took the thing I wanted to say, so I had to come up with something. I actually thought you had a great design. My only real problem with the whole design was that it was a single source, and it didn't feel like it scaled beyond that. So I thought it was a great design. You did a great job.
Thanks.
Good, great. Thanks, Josh. Great insights from our judges tonight. Awesome designs. I think we've got both Team Alpha and Team Beta covered tonight. This has been a great exchange of ideas on how to design. We are going to post up all the designs shortly after tonight's show, so get ready to share them out with the community, because we'd like to get this out to everybody to sort of take a look at what we were discussing today and where there's strengths, where there might be some weaknesses, and hopefully using the judges' input on topics, hopefully where to improve on things for future designs. Maybe not these ones, but maybe something you're doing at the office or something like that. So with that, I'm going to throw it back to Eric, and because I think we've covered all the participants.
Yeah, we've got everyone covered. So again, I want to thank all of our participants, all of our judges, all of our viewers, and of course all of our sponsors. These folks are working towards some great prizes. I tell you, if it wasn't for the fact that I'm running this thing with Angelo and Melissa and Jonathan, believe me, I'd be in competition for this, because I want to get that Zerto Home Lab sitting on my desk over there. Unfortunately, I think we're not allowed to do that. There's some crazy contest rules that probably prohibit us from doing just that. But just the same, again, the designs were really well done. This is a very open-ended design challenge, which is one of the most difficult to deal with, because you're effectively given no limits, no constraints, and a very limited set of requirements. And through the process of information gathering, you develop constraints and you list those out. And there are different levels of that being done within. Part of what being a virtual design master is, and why we bring this competition up, is to take folks and be able to let them stretch their wings a bit more into areas where they may not necessarily get to touch these at work. We don't always have opportunities to touch application infrastructure or do other work to extend to networking and storage and all this stuff. Some of us do more of one or less than others. The interesting thing is that everybody did do that, and there were areas where folks said, I'm going to touch on this a little bit because it's part of the requirements. However, they didn't have a listed strength there. So the good thing as well is finding our own limits in what we're doing, and this is exactly what the community itself does. Is we're here to be peers for each other. And we've got an incredible group of judges that are helping us out here by offering their time to evaluate our solutions. And again, we've got a peer group now who are effectively, you're opening the doors to make other people see that this kind of stuff is possible in a very short time frame. So I've got an incredible respect for all the work that's been done. Again, unfortunately, we are winding down to a final result, and part of that is that we're going to have to let a few folks not make it on to challenge number 2. What we want to do right now is we're going to highlight, that we had a great competition. Again, at the end, just after the hangout, the folks that are in challenge 2, you're going to get an exciting new email. We're going to explain that in a few minutes. But for Angelo, if you want to talk about the unfortunate news that it is the end of challenge 1, and with that, it's going to be the end of the road for a couple of our competitors.
Yeah, this is a difficult part. I do want to say thank you to everyone that's participated. These designs were really exceptional, but we did have to, let's say, vote some people off or not allow them to move on to the next round of the competition. The judges have decided, and the following 3 people will not be moving on: Tom Howarth, Anthony Chow, and Seth Forgosh will not continue in the competition. We do want to thank them for putting in a lot of effort. I know following Seth and Anthony on Twitter, they were really into it. Anthony, just in particular, was mentioning how much he was learning while he was doing this. So that's really our goal in this competition, to help folks learn, help them increase their knowledge, and help them become better at what they do every day. So with that, Eric, I'll pass it back to you.
Again, yeah, this is the terrible part of the day. It just feels we're losing some good friends here. But the good thing is we're all going to stick it out through the rest. We're all going to support each other and watch this as it goes on. The designs that came through were incredible. Tom had a particularly interesting situation. He had some challenges in his own production environment that actually took away his time, and he wasn't able to complete his design on time. Tom is in a particularly interesting situation because he was actually splitting the line on actually joining us for the judging portion for this year. And as a result of Tom's challenges where he wasn't able to complete on challenge 1, Tom's actually going to move over, and you're going to see him join us throughout the rest of the series on the judges' side. So again, Tom's in the UK, so he's got a real time zone adventure to deal with. So he's going to help us offline with evaluating some of the stuff. So again, Anthony and Seth and Tom, we want to thank you very much for the work that you've done. Everybody else from Team Alpha and Team Beta, you've all done an amazing job. And as part of that, for the folks that are moving on, it's time to talk about exactly what you're moving on to. In Challenge 1, we were faced with an open-ended, incredible design that had to be put forward. That included requirements, application structure. It included an amazing amount of information that you had a choice as to how much you put in there. So the interesting thing is that some of that's going to come forward, and we're going to talk about why. So Melissa has been kind enough to make all of our lives a little bit more difficult as we head into Challenge 2. We thought this was tough with Challenge 1, but as we head into Challenge 2, the depot at Cape Canaveral is almost online, and the depots in the Netherlands, Australia, and New Zealand are going to be coming online soon as well. The next obstacle in the infrastructure is going to be the base on the moon. The moon is going to be used as a stopping point on the way to Mars. So in addition to serving as the human race's new home until the colony on Mars is finished, this is going to be a very interesting part of the journey. Now, due to the way that the base was constructed, we have serious power, cooling, and space limitations. So you must scale the design down to fit into half of a data center rack, or 21U in total of space. In addition, the moon only supports IPv6. So you have to support an IPv6 infrastructure with your design in order to get to the moon. You must use the same vendors in the design that you're working with. You can use different product lines in order to scale them into the smaller design space, but effectively you're still locked into your vendor because there's an assumption that that's what's available to you. You must tell us what the configuration maximums are for the new design. Because you're scaling down, we have to understand what you're scaling down to. So we want to talk about maximum hosts, maximum VMs, storage capacity, network capacity, and what your failure tolerance is with your new half-rack design. Now, again, we talked about scalability, so it's very important that the design itself should be scalable, although it's got to be compartmentalized to fit into a small space. In order to remove the risk of a single point of failure, such as a complete support team turning into zombies, we will be moving forward with 2 existing infrastructure designs. The twist is that Team Alpha is going to be using a design from Team Beta, and Team Beta is going to be using a design from Team Alpha. So at the end of the night, you're going to be given your design from the opposing team, and you are going to use that as the baseline to build your 21U design with constraints, limitations, and understanding how to adapt as you head into Challenge 2. Just as with Challenge 1, designs are going to be submitted in PDF format, including designs and IP topology for your IPv6 infrastructure. Here's a little hint. If there are limitations around IPv6, it's good for you to spot them now. Let me tell you, we've got some really eagle-eyed judges. So if there's something that's out there that may not support it today, it's good to highlight that now, because you don't want to find that out when you're defending in Challenge 2. So we want to thank everybody. We want to thank Zerto. We want to thank Veeam, HP, Jason Langer at virtuallanger.com, VMware Press, Ivan at ipspace.net, all of our judges, all of our amazing competitors, the creative team, Angelo, Melissa, Jonathan, and of course myself. I want to thank everybody and for all of this work. It's been an incredible start to the year, and let me tell you, it's tough to know that we're moving on with less you folks. We're proud of what we've done so far, and we're going to be really proud of what we head into Challenge 2 with. So with that, I want to say thank you to everybody, and get ready, because this one's going to be an adventure. And we'll see you next week on Thursday at 9 p.m. for the defense of Challenge number 2. Thanks, and have a good night.